Hello. My name is Nate. I'm a software engineer at a company called Prefect, and today I kind of want to talk about um, pydantic validation that is possible specifically in the pydantic 2 world that I think is pretty exciting, even though it's a pretty niche topic. I think if you spend a lot of time building data models and checking that values that go into those data models are correct, I think you may get some value out of this. So what I plan to cover in this video is a couple things. Basically what I want to cover is pydantic validation. I think most people, if you're watching this, probably care about validation and understand why it's useful. Just basically avoiding runtime errors, making sure that people understand why a certain value is not correct if they provide an incorrect value. Actionable errors are always nice. A little bit about like the pattern that has existed in pydantic and ways that we can improve that using the new constructs in pydantic 2. So that's going to be like annotating types with field or functional validators, as they call them, and then like some applications of these things that I think are somewhat interesting. So what I have here is just a bare bones blank project. So I'll just do a git init in case I want to push this. I will give myself a virtual environment with 312 and activate that, and I will pip install pydantic. So that'll give me pydantic 2.7, which has a bunch of new stuff that I'm not going to really cover in this video, but a lot of performance improvements. So I will open up VS Code, and then I will just get ourselves a new file. And the first thing I wanted to talk about is just basically what has always existed in pydantic. So we could always do, let's tell VS Code that this is Python demo.py. We'll say from pydantic. Oh, do I need to select a virtual or a interpreter? Yeah, let's select an interpreter. Also, VS Code's kind of dumb sometimes and doesn't pick up on my virtual environment, but that's okay. Pydantic. Let's get ourselves a base model and a validator, which is actually deprecated in pydantic 2 in favor of field validator, but we'll talk about that. Basically, if I have some class foo with Copilot knows what I want. Basically, like, oh, this is actually not a great value. I don't want to access. Let's say foo has some field a, and then we wanted to say that validator, a must be positive. This is actually a great example. So we use the validator to check something about the value, in addition to the fact that pydantic will already check that this is an integer. I think validators are after by default. Yeah. So basically, there's like 3 stages to validation in pydantic. There's the raw input that a user gives when they're instantiating a model, like an instance of this foo model. Like I say foo and a is equal to 1. And before anything else happens, you do like pre-validation on the inputs, or you can do. And then pydantic would do its like boilerplate validation, like is this thing an integer? All the things that pydantic would do for you out of the box. And then there's like a period after that native pydantic validation that you can also do stuff if you want. Pydantic docs have a great coverage of all this stuff, but basically you'd have something like this in the past. And this is fine, this is great, but right now this validation on A is coupled to this definition of foo, such that if I have a different model like called bar that does more or less the same thing, right now I've basically duplicated this validation logic across 2 different model definitions, and there's no real difference between the validation logic. So this brings us to the first new thing that's kind of cool about pydantic 2. So if I go up here and instead I say from typing import annotated, I could define myself a positive integer, and Copilot has no idea what I'm trying to do here, but that's okay. We'll say annotated, and we're gonna grab ourselves, instead of this thing, we'll grab field, and then we're gonna annotate an integer. Yeah, there we go. Now Copilot knows. I don't think we want, we don't want a default value or anything that looks like that. All we want is this. We basically want to annotate an integer with the information that we get out of a field that this thing is greater than GT, greater than 0. Sorry. So we're basically baking in the validation, or baking in the information about what this thing should be into this type using annotated. So we're annotating this to type with the information we care about, validating. So now instead of duplicating this validator on each model, we can just say that instead of an integer, we want a positive integer for these things. So let's see and make sure that this works. Copilot is once again just doing stupid things. Oh, it's inheriting. Okay, it's not as stupid as I thought, but it's kind of weird. Let's get a terminal and let's run these things. What did I call this? Demo. So let's actually give some bad values so we can show the entire point of what I'm talking about. So let's say that we have -1 and -2 here, and then we'll go back here, run that again. Yeah, okay, so for foo, we get, oh, it fails out. But yeah, we see what we would expect, which is that the validation on the model fails because it cares about making sure that we get a positive integer, which is defined and validated because the type itself has this information about inside of it about what it needs to be a valid positive integer. So you can use field to annotate types to get self-validating types so that you don't couple validation logic to model definitions, which I think is pretty cool. Another way to spell this, which is more flexible, I think, is to use what they call functional validators, which I guess are pretty similar to the OG one that I showed earlier, but it's also making use of this annotated idea. So what I can do is I can grab myself an AfterValidator, which is another annotation. So basically I can say, what's a good example? Let's just say that assert validate number somehow complicated. Like say I need to just write a function in order to validate my my type, but I also don't want to couple that validation logic to the model definition where this type is going to be used. So I can do something like, I'll just stay with the same example, validate number somehow. And so now I'm going to take this and I'm going to validate, I'm going to annotate, the integer with this AfterValidator, which takes the function that I want to use to validate this thing. So it's, again, I can validate it in a functional style the same way as I could with the decorator validator on the model, but I don't have to actually put it on the model. It's all baked into this type. So now I can go do the same thing. First one should work, second one should fail. Cool, that makes sense. Must be non-negative. Great. Okay, so these are two things that I think are pretty cool. And then lastly, we'll get into a use case for this stuff. Let me go and grab something I was just looking at. So if we grab this, we'll go to a new file and we'll say this is llm.py. But basically, I spent a lot of time working on, I need to pip install Marvin, which is a library for basically producing functional prompts for LLMs using OpenAI. But basically, I'll step through this. So say we have, I'll hide this for now so it's just not distracting. So basically we have this thing that we're just talking about with this AfterValidator business, where we have a function that takes in the value that we want to validate. It checks something about it, and then we annotate an integer or a built-in type with this AfterValidator, which takes the function. And so now this validation is baked into the type. And Marvin has this this primitive. Oh man, I also need IPython. So if I say import Marvin, we can say like Marvin function list fruit. Let's say n is equal to 3. I can say like list of string, and we get the LLM to work as the runtime, generate a list of fruit. And I don't need any source code. The LLM is acting as the runtime. So I'll say, oh, hold on. What have I done here? Int equals 3. There we go. I'm surprised that was even like, anyways, that seems weird that it even let me do that. But list fruit, I call this, I get some verbose debug log, but I get 3 fruit back. And basically it's just looking at my return type on my function and asking the LLM for JSON that matches this stuff according to the docstring and signature of the function and all that. So if I go back now to what I was talking about, code, we have this Marvin function, which more or less does the same thing, except this time the type that it's asking for is a random number, which is an annotated integer that basically checks something about the type. This is a joke about random numbers that humans select. Like when asked, people often select like 42, 69, or 37. People think of 37 as like a more random number than others. But really what this shows is that, like, say we have some really complicated schema, like I write some really big old base model that has nested base models, and it's just a lot to look at. So if you ask an LLM to produce JSON that matches that schema, it might fail. And if it does, it would be cool if you could show exactly how it failed according to pydantic validation errors, and then give that information back to the LLM to re-ask. So maybe that's what I'll name this here. I'll say re-ask.py. And that's exactly what this decorator is doing. It's basically just going on top of this Marvin function and saying that, hey, if we fail, catch the validation error and just tack that validation error onto the docstring of the function, because we use that to build the system prompt, or not the system prompt, but the system prompt that ultimately constructs the list of messages that we send to an LLM when we ask for JSON out. So each time that it fails, we just tack on more additional context, and then it hopefully will learn from its mistakes by being able to see previous attempts and producing which in this case is just sort of an arbitrary choice. They're like, hey, if it's not 37, it's not a random enough number. It's a joke, but it's just, you could use this in a more reasonable setting. So if I go ahead and run this, it should produce some random number, having no idea that we want 37. It should see this error message that we're throwing on purpose. It should get sent back to the LLM in the next system message, and then we should get 37. So let's see, Python re-ask. Oh, did I move? I went someplace else. Oh yeah, okay. Python re-ask. Oh, I don't have an OpenAI API key. 1 second. Okay. Yeah, I did that. I commented it out in my my M file because I wanted to test something, but forgot to put it back. So now I'll just source my zish, activate my virtual dot venv virtual environment, and then we'll try that again. Basically what we should see, yeah, okay. I kind of want to see it fail though, so let's make it very clear that we are failing at some point. Caught a validation error, yeah, good enough. Let's see what that looks like. There's no way it got 37 right away, right? Yeah, caught a validation error. Value input, it gave like a very random number, and then we said, hey, everyone knows the most random number is 37. That got sent back. Actually, we can turn on the verbose log so we can actually see what it sent back. Wait, why didn't that work? Log verbose. I wonder why that's not logging verbose. Log level equals debug. That's probably why, huh? What happened? Log verbose input should be a valid boolean. What did I do? Oh, doi. Okay, log verbose should be true. Log level debug. There we go. There we go. Okay. So what happened is the first time we did not have any information in the prompt about wanting 37. We just asked for a random number, and then when it failed, we put this this message, this validation error that pydantic gave us back in the prompt and said like, hey, try again. And so this is very arbitrary. This isn't a good use of this exact functionality, but there's a lot of complicated schemas that you could put in this spot and basically use a cheap model, for example, ask for a complicated schema, and if it fails, show the validation errors, try again, and if it fails again, maybe you bring in a more expensive model, you call the same thing with GPT-4 instead of 3.5. So there's a lot of cool things that you can do by just sort of annotating types, using it to validate input values to those types, and then conditionally responding to the failure to perfect or provide correct values for those types. So that's pretty much all I wanted to talk about in this video. These annotated types I think are really cool. It kind of gives you the ability to do like a type repository type of deal where you can have a bunch of models that all use types from this type repo, and those types have the information about how to validate inside of them. Similarly, you can do serialization stuff on types, which maybe we'll talk about some other time. But yeah, until the next one.